Good morning, and welcome to Unit 10, which is all about gases. It is our final unit that we will be studying this year, and I'll give you a little secret. It's probably the easiest one that we do most of the year. That's why I save it for the end. Anyway, so we are going to be talking about gases. You probably already know a little bit about them in your studies when you talked about solids, liquids, and gases. So this unit might be a little bit of review for you. But there's three important things that we will be talking about when we talk about gases. The first is their volume, the second is their temperature, and the third is their pressure. So let's go over those three things in just a bit more detail. Gases are, as you know, compressible, means you can squish them because there's a large amount of empty space between the particles. Empty space. Um, there's the most empty space between the gas particles than in all of the states of matter, right? So you can compress them, squeeze them, so that the particles move closer together. Gases don't have a strict volume when we talk about volume. Solids have constant volume, liquids have constant volume, but gases do not. They expand to fill the container that they're in, right? Expand to take the shape and the volume of their container. Whether that is a small container, the room that you're in, or the atmosphere outside. Gases will expand and spread out to fit that container. As the volume of the container increases, the volume of the gas expands to fill it. Right, so, you've all heard that little thing where you open up a bottle of essential oils or perfume or something in a room, and pretty soon those molecules will spread out throughout the whole entire room so you can smell it equally around the room. Um, so that's volume of a gas. Temperature of a gas, I'm going to point this out first of all, is always measured in Kelvin. And the equation to figure out the temperature for Kelvin is temperature in Kelvin, degrees Kelvin equals degrees Celsius plus 273. Okay, so that is an important equation you're going to have to know. Lots of times the problems in this unit are written with degrees Celsius and you must convert them to Kelvin. Okay, so super important. You won't get the right answer if you don't. Okay, so this is key to solving problems when we talk about gases. Um, okay, so temperature of a gas relates to its speed, how fast it's moving, and its mass, right? And like it says here, as gas particles heat up, their speed increases, and as they cool down, their speed decreases. Okay, so gas particles, constant motion, which means they have kinetic energy. Remember, kinetic energy is the energy of motion. Okay, so kinetic energy describes the energy of the gases they're moving. Sometimes it's more when they're hot, sometimes it's less when they're cold. So, pressure of a gas. Remember, we just said gas particles are constantly moving, and they often collide with each other, obviously. I mean, how could you not? They're all bouncing around all over the place. They also collide with the walls of whatever container they're in, whether it be the room or a container, a bottle, whatever. But those gas particles are always moving around, always bouncing against the container. You can kind of see here in this picture inside the balloon, outside the balloon. Right. So when we talk about the pressure of a gas, the pressure of a gas is basically the force that it exerts on the walls of the container. So it's talking about how often those molecules are bumping into the container. right? More pressure means they're bumping into it more often, right? I think if you look at these pictures, right? I know these were talking about volume, and we made the volume smaller, um, but it also increased the pressure because there's more collisions with the wall with these gas molecules than there is with these because they have more space to move around. Right? So let's continue on. When you fill a balloon with air, the balloon expands because the pressure of the air molecules inside the balloon is greater than it is outside. So you're pushing that air in there, and the balloon has to get bigger to handle all those molecules bumping up against the walls, right? So when you stop filling, the balloon stops increasing in size because right there is where the pressure inside equals the pressure outside. Okay? So the pressure inside is the same as the pressure outside, and the balloon will stop filling, will stop expanding, right? Um, but most important to remember that the pressure of the gas is the force it is exerting on the walls, right? And it will increase and decrease, which we will see in the next section.